Welcome to this episode of Conceptual Anesthesia. So, after about two classes on ventilator graphics, we'll be seeing how ventilator graphics interact with ventilator settings. So, I'll be speaking about the settings a bit. How do you set a ventilator? What is the trigger? What are the control variables? What are the phase variables? And then we'll see how they correlate with the graphics. So, how did ventilation progress? Initially, they were iron lungs, and then came positive pressure ventilation. And nowadays, all of us may be familiar with the non-invasive ventilation, which is a then the components of a mode. The types of breath are mandatory or spontaneous. I had also told in graphics what is a mandatory breath or a spontaneous breath. We'll be seeing how is a mandatory breath generated and how is a spontaneous breath generated today. What are the control variables? What are the phase variables? And what are the conditional variables? So basically, mandatory breath is a breath that is started and ended by the machine. Or a spontaneous breath is started and ended by the patient. An assisted breath is started by the patient and ended by the machine. So in mandatory, everything is done by the machine. In spontaneous, both of the things are done by the patient. And assisted breath, it is started by the patient and ended by the machine. Now there's a primary variable which the ventilator adjusts to achieve inspiration, and that is called as a control variable. The control variables can be pressure, volume, flow, or time. It is important to recognize the fact that ventilator can control only one variable at a time. So out of these four, pressure, volume, flow, and time, the ventilator can actually control only one. And therefore, it must be either a pressure controller, volume controller, flow controller, or time controller. So what are the two commonly used? One is the pressure control and the volume control. So this is a mechanism by which a ventilator controls the delivery of inspirational gas. So the commonly used methods are volume controlled or pressure controlled. Typically, the phase variables are limit, trigger, cycle, and peep. I had mentioned this in the previous class also. What is a trigger? So how a inspiration is triggered, how you initiate a breath, that is called as trigger. And I'll be telling you types of triggers later on. Then what is a limit? Limit is when do you end inspiration? That is the limit. What is a cycle? When there is cycling from inspiration to expiration. The cycle is moving from one place to another. You're moving from inspiration to expiration. And there is a baseline peep variable, that is the positive and expiratory pressure. That is a expiratory phase variable. So trigger, limit, cycle, and peep are called as phase variables, whereas volume or pressure or time or flow can be control variables. So expiratory is the baseline peep, that is the variable, and inspiratory we have trigger, limit, and cycling variables. So let us see what happens. A is the trigger. There is the breath is triggered. B is limiting variable. C is cycling variable that switches from inspiration to expiration. And D is the baseline variable, that is the expiratory variable. So in a simple term, trigger is what causes the breath to begin. You want to begin a breath, what causes the breath to begin? So it can be time triggered, which is controlled by the machine. So you set it at a particular time, and after those many seconds or those many milliseconds, the machine will trigger a breath. Machine will start a breath. So what causes the breath to begin is the time triggered here. Then can be patient triggered. Patient triggered can be pressure, flow, or volume. Normally we have flow or pressure triggers, that is by the patient, and time triggered, that is by the machine. So with time triggering, the ventilator delivers a mandatory breath by beginning inspiration after a certain time has elapsed. So suppose you have a breathing rate set at 20 breaths per minute. So what does the ventilator do? It triggers a breath every 3 seconds. So after every 3 seconds, the ventilator will automatically trigger a breath. So this 3 seconds is a time triggered. Then if the patient attempts to breathe spontaneously during a mechanical ventilation, a ventilator must be available to measure the patient's effort to breathe. When the ventilator detects change in its pressure or flow, it is a patient triggered. So patient triggered are normally pressure triggered or flow triggered. So what happens is that the ventilator is going on and the patient tries to breathe. So now the ventilator has to detect this. Ventilator has to detect it by either a patient pressure triggering or a flow triggering mechanism, which are the two common mechanisms. And they find that if there's a negative airway opening pressure or a negative change in flow, that is detected. I'll be telling you these two in detail. So something is there is sensitivity. So to enable patient triggering, the clinician must specify the sensitivity setting. How sensitive is the triggering? How much effort is the patient going to make a ventilator trigger a breath? So this setting determines the pressure or flow change that is required to trigger the ventilator. So patient has to make small effort or large effort. This is called as sensitivity. The patient's effort that he has to make to trigger a breath. The less pressure or flow change required to trigger a breath, the more sensitive the mechanism is to the patient's effort. So if the patient has to make a less effort, that means the mechanism of triggering a breath of patient triggering is more sensitive. More sensitive, less effort. So what is pressure triggering? There is a baseline pressure in the system, and when the patient makes a negative airway opening pressure, the breath gets triggered and the patient starts the breath. So now the patient is triggering a breath. It is by a pressure mechanism and the ventilator delivers a breath. So there is a set peep with a positive and expiratory pressure, initially set at 3 to 5 centimeters of water. And if you want oxygenation, that is a separate class. How will you change the peep depending on an ARDS patient? But if you set a peep of 5 supposedly, and the patient makes an effort, you will see a dip in the graph. You will see a dip here in the pressure waveform, and that will trigger the breath. This is the way the peep is there, and this is the sensitivity. So the patient has to make this effort to trigger a breath. Suppose the peep is 5, sensitivity is -2. So patient has to make this effort, that is -2, and the threshold to trigger a breath is +3. So that is how the pressure triggering happens. What happens in flow triggering? There is a baseline or a bias flow that is there in the system. In both the inspiratory and the expiratory limb, there is a bias flow flowing. Ventilator detects a drop in the flow. So when the patient tries to trigger a breath, there is a drop in the flow, and that is what the ventilator detects. So how much flow sensitivity or flow triggering you want to set, that you have to detect. Normally we set at 2 liters per minute. So clinician must set an appropriate flow that must be sensed by the ventilator to trigger the next breath. So ventilator has a baseline flow of 6 liters per minute supposedly. This allows 6 liters per minute of gas to flow through the patient circuit during the last part of exhalation. The sensors measure the flow of 6 liters going from the patient to the ventilator and from the returning to the ventilator. So 6 liters of flow is through the circuit throughout. If the flow trigger is set at 2 liters per minute, that is the usual thing that we set, the ventilator will begin an assisted breath when it detects a drop in the flow of 2 liters. So from 6 liters, when there is a drop of 2 liters, it comes as 4 liters. So when 4 liters of flow comes back to the ventilator, that is when it triggers a breath. So there are flow measuring devices, and you have set a baseline flow of 6. The patient's trigger is at 2 liters per minute. So 6 minus 2 is 4. So when the ventilator detects that it is gone down from 6 to 4, it will trigger a breath. That is called as flow triggering, and this is the most common thing that is set in the ventilator nowadays. Now something on the controlled breathing. When a ventilator maintains the volume waveform in a specific pattern, the delivered breath is volume controlled. So if the control variable is volume, then it's called a volume controlled breathing. And here the ventilator maintains the volume waveform. So during volume controlled breathing, the volume and the flow waveforms remain unchanged, but the pressure waveform varies with the changes in lung characteristics.